Simplify 100 to the power n minus 81 to the power a, all divided by 10 to the power n plus 9 to the power a. I want you guys to do this by yourselves and see if you're going to get 10 to the power n minus 3 to the power 2a. First and foremost, guys, I am going to express 100, the base 100 here, as 10 squared. All right? All of this is to the power n. Remember, what is in bracket is equals to 100, right? Minus, so 81 can be expressed as 3 to the 4, right? To the power now a. I'm going to divide this here by 10 to the power n plus 9 right now can be expressed as 3 squared, right? Then all of this is to the power what? To the power a. Okay, guys, so let's utilize now the power rule where I'm going to be multiplying this exponent here, the exponents over here. So this is equals to, maybe let me write it here. This equals to 10 to the power n, like this. Okay, guys, so to further solve this, I want to create a condition, right, that we have been exposed to for quite some time. So what I'm going to do here, I'm going to say 10 to the power n, I'm going to put a 2 here. So you would realize that this is exactly the same thing, right? Saying 2 times n is exactly the same as n times 2. And then I'm going to say minus 3 squared over here. Then let me put the a here. All of this is to the power 2, right? So you would realize that 4 times a is the same as 2 times a times 2. And there's a reason, guys, why I'm doing it like this. You're going to see that shortly. So on my denominator, I've got 10 to the n plus 3 to the power what? 2a. So now, guys, you know a process of... Now, guys, you are more exposed to something called the difference of 2 squares, right? And you might ask yourself, what in the world, right? However, I want you guys to take note that this is a square, this is a square, and we've got the difference of 2 squares. So how does that factorize? So I'm going to have 10 to the power n minus 3 to the power 2a multiplied by 10 to the power n plus 3 to the power 2a. I'm going to divide all of that by what? By 10 to the power n plus 3 to the power 2a. And take note that at this point, 10 to the power n plus 3 to the power 2a is going to divide with 10 to the power n plus 3 to the power 2a. So this has just been simplified now. So it's 10 to the power n minus 3 to the power 2a. So what saved the day here was when I sort of... So what saved the day here was recognizing the numerator. So what saved the day here was recognizing the capacity that the numerator had to have a difference of 2 squares. and hence I manipulated my exponents here to suit that need. And voila, I got 10 to the power n minus 3 to the power 2a, as I expected. Simplify, simplify 25 to the power z minus 1 divided by 5 to the power z plus 1. I want you guys to do that by your own and see if you're going to get 5 to the power z minus 1. Okay, so 25 is 5 squared, right? To the power z minus 1. I'm dividing everything by what? By 5 to the power z plus 1, right? So I'm supposed to be applying the power rule here in this, at this case. So I'm supposed to be applying the power rule right now, right? So I'm going to say 2 times z. That's going to be 2z. But take note, guys, that if I write that in this fashion, 5 to the power z to the power 2, that is going to give me the exact same answer. Now I'm just going to say z times 2, which is the same as 2 times z. Can you guys see that? Then I'm going to minus 1 here. Divided by what? Divided by 5 to the power z plus 1. You know, take note, guys, that 1 is a perfect square, right? So 1 times 1 is 1. So on my numerator, I have, once again, the difference of 2 squares. I've got the difference of 2 squares, and I'm going to use this to my advantage to simplify this thing further. So now, this is going to equals to, this is going to equals to, so now this is going to equals to 5 to the power z minus 1 times 5 to the power z plus 1. So these are the brackets that we get from the difference of 2 squares. Then divided by 5 to the power z plus 1. And as you guys can already see, that this is going to divide with this over here. Okay, and then I'm left with 5 to the power z minus 1, right? Once again, what saved the day here was recognizing the potential that the numerator had to actually result into a difference of 2 squares. Then I did that, and then that extra bracket there actually divided with my denominator, and then I simplified my expression to this. Simplify 9n to the power 5g divided by n to the power minus 3g multiplied by z to the power minus. Simplify 9n to the power 5g divided by n to the power minus 3g multiplied by z to the power minus 4g minus 1. All of this squared. This equals to, firstly, guys, I am going to simplify the bases, right? 9 here, 9 can be expressed as 3 squared. That is 3 squared. Simplify 9n to the power 5g divided by n to the power minus 3g multiplied by z to the power minus 4g minus 1. All of that is to the power 2. Do this by yourself at home and see if you're going to get 81n to the power 16g multiplied by z to the power 8g minus 2. So my first focus here is on the 9 in the bracket. 9 can be expressed as 3 squared, right? and then n to the power 5g. Then I divide all of these by what? By n to the power what? Minus 3g multiplied by z over there to the power minus 4g minus 1. All of this is squared right here. So what I'm going to do now is that what I'm going to do right now is that I am going to multiply all the exponents with 2. So we've got inside the bracket 3 to the power 2 times 2, that is 4, n to the power 5g. So 5g times 2, that's going to be 10g. I'm dividing everything by n to the power minus 3g. Minus 3g times 2 is going to be minus 6g. Then multiplied by z to the power minus 4g minus 1. And then I'm going to multiply that by 2. That is going to be minus 8g minus 2. Can you guys see that? Okay, perfect. So now, what is going to happen is this. I've got n over here. I've got this n, and I've got this n. I'm going to utilize the quotient rule, right? Because the bases are the same, so I'm going to subtract the exponent. So that's 3. That is 3 to the power 4, n to the power 10g. That is the exponent of the numerator minus the exponent of the n of the numerator minus what? The exponent here, which is minus 6g. Minus 6g, right? And then, okay, maybe let me still divide with my z to the power minus 8g minus 2. Okay, guys, so now applying the quotient rule here, 3 to the 4, and then 10g minus 6g. What does that actually mean? It's going to be 10g plus now 6g. I'm dividing everything by z to the minus 8g minus 2. This equals to what? 3 to the power 4, 10g plus 6g, that's going to be n to the 16g divided by z to the power minus 8g minus 2. So now, guys, I'm done here. I'm just going to take z on top, so that I'm going to take z to the power minus 8g minus 2 to the top, and I'm going to change the sign of the exponent. So 3 to the 4 is 81, n to the 16g, z to the power now 8g. So you see the sign is changed, plus 2. So this is my simplified answer. Simplify 8 to the power. Simplify 8t to the power 5. Simplify 8t to the power 5 multiplied by f divided by t to the power minus 5 times f multiplied by y to the power minus 3c plus 4 all squared. Do that by yourself and see if you're going to get 64t to the 20 multiplied by y to the power 6c minus 8, right? So this is equals to, firstly, looking at my bases here. Let me first sort out what's in brackets, right? So 8 can be expressed as 2 cubed right here, and then t to the 5, f is to the power 1. I'm dividing everything by t to the power minus 5, f to the power 1, y to the power minus 3c plus 4, all squared. So what I'm going to do now is that I'm going to multiply all the exponents inside with these 2. And then that is coming from the power rule. So it's 2 to the power 3. It's going to be 3 times 2 is 2 to the 6th. And then t to the power 5 times 2, so it's going to be 10. F to the power 1 times 2, that's going to be f squared, divided by t to the power minus 5. Minus 5 times 2, it's t to the power minus 10. F to the power 1 times 2, it's f squared. Y to the power minus 3c plus 4. So I'm going to multiply 2 times negative 3c plus 4. That's going to be y to the power minus 6c plus 8. Okay, guys. So now what I'm going to do is that I recognize that there is t to the 10, t to the minus 10 here. Those bases are the same. I recognize f and f, that is also the same. And then y is just chilling over there on its own, right? So 2 to the 6 over there. And then I'm going to bring the t that is on my denominator on top there. So what I'm going to have t to the 10, which is this one, minus 10. You see that? So now I'm using the quotient rule on t to the 10 and t to the minus 10. So what I'm doing is that I'm going to subtract the exponents, and of which, as you guys can see, that this exponent was the one that was on top. This one was the one that I had underneath. You know what I'm saying? Okay, looking at f now, f squared, that's the 2 that was on top. Then I've got another there, f squared. So it's going to be 2 minus 2, right? And then with regards to the y, maybe let it chill there for some time. Y to the power minus 6c plus 8. So this equals to what? 2 to the 6th, 10 minus 10. So that's going to be 10 plus 10. So it's t to the 20. F to the power 2 minus 2, that's f to the power 0, divided by y to the power minus 6c plus 8, right? Okay, guys, so right now, f to the 0, what is f to the 0? So this equals to 1, right here. So I have 2 to the 6th, t to the 20, and then this y, I can bring it here, all right? So now what happens is that its sign, the sign of its exponents is going to change. So it's going to be minus, the minus 6c is going to be now plus 6c minus 8. You know what I'm saying? So 2 to the 6th, that's going to be 64, t to the 20, y to the 6c minus 8. So this here is my final answer.